Hello again, everyone. Hope you enjoyed your fake break and were able to get the review packet done. So we're moving forward now. If you don't have a calculator with you right now, go get it, because even I'm using my calculator. All right? So stop the video, go get your calculator, and then come back. All right, today we're going to talk about the interior and exterior angles of polygons. All right, we're going to develop a pattern, because math is the study of patterns. And let's see how you can do with this. You're supposed to be working in groups right now, but obviously that's not going to happen. All right, so the first thing we're going to talk about is the triangle. We know it has 3 sides. And how many triangles are in a triangle? Well, that would be 1. We know that the sum of the interior angles is 180 degrees. And the measure of each interior angle, now it has to be a regular polygon. So a regular triangle, all sides congruent, all angles congruent, would be an equilateral triangle. And because each angle is equal, each angle on the interior would be 60 degrees. That's the 180 divided by 3. So 60 and 60. All right, so 60 degrees for each interior angle. At each exterior angle, all right, now remember what an exterior angle looks like. It's the 2 angles that form a line. So that would have to be 120 because there's 180. If I did the exterior angle up here, it would be 120. If I did the exterior angle right here, again, 120. So because it has 3 sides and it has 3 interior angles, it has 3 exterior angles. So 3 times 120 would give me 360 for the sum of the exteriors for a triangle. Quadrilateral has 4 sides. And I'm going to draw a regular quadrilateral. Remember, all sides equal and all angles equal. So that would be a square. So let's make sure I do something that looks pretty much like a square. That looks pretty good. All right, now there's rules when you have to figure out the number of triangles. You go from a vertex to another vertex. But I'm also not allowed to cross any lines that I've drawn. So if I come from this vertex, it would cross the line, and if I go from this vertex, it would cross the line. From this vertex to this vertex is the side. So in a quadrilateral, I can make 2 triangles. The sum of the interior angles of any quadrilateral would be 360 degrees. The measure of each interior angle for a regular quadrilateral, which is a square, would be 90 degrees. Each one of these angles would be 90. Okay, that's the 360 divided by 4. All right, if the interior angle is 90, then the exterior angle is also 90. And I could do it here. I could do it here. I could do it here. I'm just extending the side and doing an exterior angle. Again, I'm going to have 4 interior angles, so 4 exterior angles. The sum of the exterior angles is 1, 2, 3, 4 times 90, so 360. Okay, a pentagon, 5-sided polygon. If I draw a regular pentagon, I'm going to draw it like a house with the sides that are kind of slanting in. So that's pretty good for a regular. All right, so it has 5 sides. Let's see how many triangles I can make. So let's start at this vertex. And I'm going to connect to that vertex. I'm not going to do this one because that would be a side, as would this. Now, I'm going to do another one to that vertex. If I come to this vertex, I would have to cross, and I'm not allowed to do that, and the same with here. This vertex would give me the same one and the same one. So there are 1, 2, 3 triangles in this pentagon. Now, let's look at the pattern. I went from 180 to 360. I have 2 options here. it either doubles, so this would be 720, or it goes up by 180, which would give me 540. Those are the two things that I would have to consider. Now, the whole idea of doing this triangle thing is because I want to get the three triangles, each 180 degrees. So this would be 3 times 180, so 540 is my correct value. All right. If you were working in groups, it would take a little more than this to do it, but obviously I know what has to happen here. All right, so now it's a regular pentagon, so it has 5 angles. So I would take my 540 and divide that by 5 to figure out that each interior angle would be 108 degrees. Now, to figure out the exterior, well, if one is 108, I'm going to do it over here where I have a little more room. The exterior angle, remember you just extend the side, would have to be 72 degrees because the angles form a line, so they sum to 180. So that would be 72 degrees. Since it has 5 interior angles, it will have 5 exterior angles. So 5 times 72 360 again. So what do you think is going on here? All right, let's see what happens with the next one. A hexagon has 6 sides. How many triangles do you suppose it would have? All right, well, to draw a hexagon, I'm going to do 2 isosceles trapezoids. I'm not going to make that line, though. Okay, and then here's another one. Okay, let's start from this vertex. I could connect to this vertex, and I could connect to this vertex, and I could connect to this vertex. Now let's see if I go from here. Oh, anything I do, I'm going to have to cross the line. This would repeat, and this would cross lines. So there's 1, 2, 3, 4 triangles in a 6-sided polygon. All right, if there's 4 triangles, I have to do 4 at 180. So I do 4 times 180. And that's going to give me 720 degrees for the sum of the interior angles. So this 4, 5, 6 would be 720. All right, each interior angle. So I have 720 total. I have 6 angles. So I need to divide my 720 by 6, and I get 120. Okay, if this is 120, if I extend this, this would have to be 60 right here. All right, because the interior plus the exterior is going to be 60. This will be 360 because 6 angles at 60. Does everybody see the pattern coming here? All right, also look at this. This is going down. This is going up. This is going up. The 360 seems to be consistent. So I'm just going to fill in the 360 all the way down this column because the sum of the exterior angles of any polygon is 360, which is a great thing because we can work with the exterior all the time. Okay, heptagon or septagon, it's known by both names. And that's going to give you 7 sides. Well, what do you think? How many triangles is it going to give you? Hopefully you've noticed that it's, as the sides are going up, the triangles are going up. So I will have 5 triangles. So 5 times 180. The sum of the interior angles would be 900. All right, there's going to be 7 angles because there's 7 sides. So I'm going to divide the 900 by 7. Okay, now you're going to get this, well, it has to be a repeating decimal, but we don't know what the repeat is. And that's going to be 128.57. I'm going to go 4 places because that's pretty standard. Now, to figure out the exterior angle, I need to subtract that from 180. So 180 minus, and I'm going to use second answer on my calculator, and that's going to give me 51.428. And again, I'm going to go 4 digits and round correctly there. Now I can double check myself here. The 7 angles better sum to 360. So I'm going to leave that number in my calculator and do times 7. And yeah, that looks good, 360. All right, I'm going to go a little different doing my octagon. I know an octagon has 8 angles. And if it's a regular octagon, each one of the angles on the outside, they're all equal. So I could take the 360 and divide that by 8. Whenever I can, I'm going to work from the 360 because it's always there waiting for me. Well, if an exterior angle is 45, the interior angle has to be 180 minus second answer, and that would be 135. Well, there's going to be 8 angles, so I'm going to take that 135 and multiply that by 8. So that's going to be 1080. If I divide that, sorry, hold on. If I divide that by 180, that means there must be 6 triangles, and I know there's 8 sides. Okay, do you see it works forwards and backwards? So depending on what information you're given will be the way you go with it. Again, that 360 is a beautiful thing. You really want to work with it if you can. All right, I'm going to slide this up so we have the rest of this in the picture. Okay, let's see. Nonagon, 9 sides. How many triangles? All right, I'm trying to turn this off, and it's really just not going off. Hold on. All right, at least it's lower. All right, so it has 9 sides. It will have 7 triangles. 7 times 180. That's 1260. All right, that's the sum of the interior angles. All right, there's 9 of them, so I'm going to take the 1260 and divide that by 9. And I get 140. All right, if an interior angle is 140, the exterior must be 180 minus 140, so 40 degrees. Let's double check. It has 9 sides. Each one is 40. 40 times 9 is 360. We're good. Decagon, 10 sides, 8 triangles. Decagon, like decade, that's 10. All right, 10 times 180 is going to be 1800. Oops, I'm sorry. 8 times 180. 8 times 180 is going to be 1440. All right, 1440 divided by the 10 angles is going to be 144. 180 minus 144, and that's going to give me 36. If I have 36 degrees and 10 exterior angles, 360, we're good. Okay, a dodecagon, that's going to be 10 plus 2, so that's a 12-sided figure. Now, I know some of you are going to put a 9 here. It's not going to be 9. Think about what it's going to be. Hopefully, you can see it's always 2 less triangles, so there's going to be 10 triangles total. So 10 times 180 is 1800. All right, 1800 divided by 12, because there's 12 angles, is 150. If an interior is 150, then the exterior must be 30. 30 times 12 gives me the 360. We're good. Okay, so now let's do it with a nice big number. Let's say it has 50 sides. Okay, so a 50agon. That is not the real name, but you get the idea, I hope. All right, let's look at this pattern. It has 50 sides. Well, 12 and 10, 10 and 8, 9 and 7. It would have 48 triangles. Always two less. So 48 times 180, that's going to give me 8640. All right, now I have to take the sum of the interiors and divide it by the number of interior angles. So we're going to divide by 50. All right, according to my calculator, 172.8. All right, if there's 172.8 on the interior, 180 minus second answer. Answer is on the negative key down on the bottom right. 7.2 for each exterior angle. Let's double check that. Do times 50. And there's my 360, so that's good. All right, how many should we do here? Let's do a 90agon. Okay, think about it. How many triangles will there be? Well, there's going to be 90 sides, so 88 triangles. All right, 88 times 180 is going to be 15,840. All right, I need to divide that by the 90 interior angles. So divide by 90. Each interior angle is 176. Actually, that worked out nice, didn't it? Because now I know that each exterior angle is going to be 4. All right, so now I want to write some formulas that will tell me how to do any one. If I give you a 5,000-sided polygon, you would be able to do it. So n sides, how do we figure out how many triangles? Well, when we're looking at the pattern, it's always 2 less. I certainly don't want to draw the 90-sided figure because actually, hopefully, you can see as you add more and more sides, it becomes more and more like a circle. So no matter what, no matter how many sides you give me, I know there's that many less, 2 less triangles. So the number of sides minus 2 represents the number of triangles. When I want to figure out the sum of the interiors, well, I take the number of triangles and multiply it by 180. Well, how did we figure out the measure of each interior angle of any regular entagon? Well, we took the sum and we divided it by the number of sides. How did we figure out the exterior angle? We did 180 minus the interiors, n minus 2 over n. All right. Hold on. Okay, hopefully that worked. I don't know. But check this out, guys. It would have been easier to go backwards if all we wanted was an exterior, because all we would have had to do was 360 minus, divided by the number of sides. Then we could take that number and work backwards from there. If I know an exterior, it would be 180 minus the interior would be 180 minus the exterior, so 360 over n. All right, if you remember, this is the number of triangles. This is 180 times the number of triangles. Okay, I'm going to do the class worksheet on a separate video because the last one messed up. I think it was too long. So take a break, come back, and watch video 2. Thanks, guys.